Hello everyone, welcome to today's lecture on entertainment electronics. Entertainment electronics is one of the most interesting areas of the electronics because it deals with the devices we use every day for listening to music, watching videos, recording audio, and displaying digital content. In this lecture, we will study different input devices like microphones, output devices like loudspeakers, modern display technology, storage devices, and digital imaging systems. Let us begin with the microphone. A microphone is an input transducer. A transducer is a device that converts one form of energy to the another. In case of a microphone, it converts sound energy into electrical energy. Whenever a person speaks, sound wave travels through the air and strike the diaphragm of the microphone. The diaphragm is a thin flexible material made of a paper, plastic or aluminum. As the diaphragm vibrates, these vibrations are converted into electrical signals. These electrical signals are then applied to an amplifier and recorded or transmitted depending on the application. Today, microphones are used almost everywhere in classrooms, mobile phones, laptops, television studios, public announcement systems, conferences, online meetings, and music recording studios. Without microphones, voice communication and sound recording would not be possible. Types of microphones. These are the several types of microphones, each designed for different applications. The carbon microphone was widely used in early telephones because of its simple construction. The crystal microphone uses the piezoelectric effect to generate electrical signals. The dynamic or moving coil microphone is one of the most common microphone used for stage performance because it is rugged and produces good sound quality. The condenser microphone offers excellent sensitivity and is widely used in professional recording studios. The ribbon microphone provides natural sound reproduction and is preferred in broadcasting applications. Finally, the wireless microphone eliminates cables and allows users to move freely during speeches and performances. In next few slides, we'll study each microphone individually. Carbon microphone. It is one of the most earliest microphone designs. It consists of carbon granules placed between two metal plates. When sound waves strike the diaphragm, the pressure on carbon granules changes. This changes the electrical resistance of a carbon particle. As a result, the current flowing through the microphone varies according to the sound signal. Although carbon microphones are inexpensive and simple, they produce more noise and lower sound quality compared to modern microphones. Today, they are rarely used except in few special communication systems. Next is crystal microphone. It works based on the piezoelectric effect. Certain materials such as quartz generate an electrical voltage whenever mechanical pressure is applied. When sound wave strikes the diaphragm, pressure is transferred to the crystal. The crystal produces an electrical signal proportional to the sound. Crystal microphones provide good output voltage without requiring an external power supply. However, they are sensitive to temperature and humidity, making them less suitable for modern professional applications. Next is dynamic or moving coil microphone. The dynamic microphone is one of the most commonly used microphone today. Its operation is based on Faraday's law of electromagnetic induction. Inside the microphone, a lightweight coil is attached to the diaphragm. This coil is replaced inside the magnetic field of a permanent magnet. When sound waves move the diaphragm, the coil also moves. Due to electromagnetic induction, a voltage is generated in the coil. This voltage becomes the electrical representation of the sound. Dynamic microphones are durable, inexpensive, and can withstand high sound pressure levels. This is why they are widely used for concerts, public speaking, classrooms, and live performances. Next is condenser microphone. A condenser microphone works using the principle of variable capacitance. It consists of two closely spaced plates. One plate acts as a diaphragm while other remains fixed. When sound waves strike the diaphragm, the distance between the plates changes. As the distance changes, the capacitance also changes. This varying capacitance is converted into an electrical signal. Since condenser microphones are extremely sensitive, they produce very clear and accurate sound. They are widely used in recording studios, podcasts, broadcasting stations, and professional music production. Unlike dynamic microphones, condenser microphones usually require an external power source like phantom power. Next is ribbon microphones. Ribbon microphones uses a very thin metallic ribbon suspended between two magnets. When sound waves strike the ribbon, it vibrates inside the magnetic field. According to electromagnetic induction, a small electrical voltage is produced. Ribbon microphones are well known for their warm and natural sound quality. Because of this feature, the ribbon is extremely delicate. These ribbons require careful handling. They are mainly used in recording studios, especially for recording vocals and musical instruments. Next is wireless microphone. As the name suggests, a wireless microphone operates without a connecting cable. Inside the microphone, a small battery powered radio transmitter converts the audio signal into a radio wave. These radio waves are transmitted to a nearby receiver. The receiver converts the radio signal back into an electrical audio signal and sends it to the amplifier or recording equipment. Wireless microphones provide freedom of movement, making them ideal for stage performances, television programs, seminars, sports events, and classrooms. However, they require battery power and proper frequency management to avoid signal interference. Next, we'll see the characteristics of these microphones. To select a suitable microphone, we need to understand its important characteristics. The first characteristic is output level, which indicates the strength of the electrical signal produced by the microphone. The second is frequency response, which specifies the range of frequencies of the microphone can capture accurately. The third is output impedance, which determines how efficiently the microphone can be connected to amplifiers and other audio equipment. The fourth is characteristic directivity, which is also known as pickup pattern. It indicates the direction from which the microphone receives the sound. Some microphones capture sound quality from all directions, while others capture sound mainly from the front. Selecting right microphone depends on the application, required sound quality, surrounding noise, and recording environment. So that's all about microphones. As a part of entertainment electronics, so we have completed a part of microphones. In the upcoming lectures, we will discuss about loudspeakers and the output devices. So thank you for watching this lecture.